Okay. So, do you have an idea of where to start, or should I just start asking questions?
I would guess that the top is kind of a good place to start, like directory structure, main, probably directory structure first.
Okay.
Okay, so let me see. I think app support, as you know, is app support.js is the things that are needed to load the client. And that's before the actual client application starts. And I think it would make sense to actually move that into the client application and rewrite it in Rescript. But that's not where we are now. Then if we look in source, so there's Prelude. Prelude is like a set of things to sort of load at the top of the thing. So if you kind of open that function or open that, and you see there's like JSON stuff, there's T stuff. This all just got a bunch nicer when I merge my PR, but and then like recovery stuff, which is part of the error reporting as well. And then if you have a look at core, it's kind of a similar thing, but the next level up. Simple things like encoder functions, that's for JSON, ID, program types, runtime types, you know, the things that are kind of part of the application, alongside account types, which is, you know, part of the user. So it's kind of core in a sense. And then API. So API, literally, it's just, you know, there's one of these for each API that we call. I think we would like to move these into components so that components have some sort of control over the APIs. But one of the reasons that they're here is because in API.res, we use things from the model. I guess we'll come back to that in a minute, but the model has, I think it's just the CSRF token. Or I guess there's a version header as well. So there's you know, some things that we loaded from the model that would be better. That sort of type. So a lot of things are organized the way they are because of the dependency hierarchy.
I see.
So if you want to be able to read the model, then you need to be loaded after where the model is defined. And then if you also define a type in that file, which is part of the model, then you have a cyclic dependency, and you can't do that. So a lot of the time things are split according to that. And in the future, we'd like to instead split things into components in various ways, and sort of have things really like not have the model know a whole lot about the thing, and just sort of propagating events into it and pushing things around. Okay, so analysis. Broadly, analysis is same as on the back end. Analysis is a little bit broader than just like running the code to get the results. Things like unlock DBs and sort of anything that's to do with running the program tends to fit under analysis, but especially traces.
What besides traces? So unlock DB. Yeah, I've been thinking of this as anything that's required to play back traces or to render them. What else fits in there besides unlock DB?
I mean, say for example the worker stats, right? So there's
okay.
It should be in there, but it might not be. Static deploy is a good example. We should really rename that. It's a terrible Yeah.
Okay.
Cool. And then forms. Forms is an interesting one. So these are all the types that we had to do when Dark was a little bit more of a form editor. So the first version, maybe the second version of Dark, you were kind of like filling in the AST like it was a form. And it wasn't at all like typing, it was literally you're filling in boxes. And that persists when you're filling in parameters to functions, for defining DBs and for defining the headers of handlers. And there's a really poor kind of connection between forms and fluid. And so directionally, we would like to completely remove forms and then extend fluid over anything that's really editable, including things like function parameters and that sort of thing.
Yeah, I'm curious what that looks like. Okay.
Okay, so fluid. Fluid is big. There's a lot of stuff in here. So this is everything to do with how we edit the programs in Dark. So there are there's like the program definitions, expressions, and patterns. There's how they're tokenized, there's clipboard stuff, there's where the position of the cursor is, there's things like refactoring and autocomplete and feature flags, and they all live in here.
Okay. Yeah, I'll have more questions, but we can continue going and follow up there.
Package is probably very small. I think that's just to do with the package manager. Really not much in there. Honestly, not a great place for it, but I think we should rethink that and probably put it in a similar place with top levels. Top levels. So a top level is the word that we use to describe handlers, databases, functions, and types. And so this is kind of anything to do with that or to do with their UI on the canvas. So like curl command lives in here.
Okay. Do you see these staying where they are or becoming more components and fitting into that model?
I think
I guess I was just surprised to like some things are in components and they make sense there, and then other things feel like they could be in components, but they're not.
I think they could be, these could be components. I think they sort of like predate them. And so there are things like updating the model and sort of like fetching the, let's say, handlers are fetched from the back end. But I think the display of handlers and the interaction around them could be a component, whereas the actual code or like how the code is fetched from the back end and stored in the model, I think would be its own thing, because that's sort of like pervasive throughout the app.
Okay.
Components. There we go. That's a good. Well, so this is really a mishmash of things, and it's not particularly divided out well. We're only just getting started with components in the sort of React kind of sense of something that has its own model, its own messages, its own views. And this doesn't really reflect that. These are just kind of like things that we managed to pull out. But I think we would like to get to the place where there is like some consistency in how we define components. I think the settings is probably the first, real actual components thing that we have there. Maybe secrets. I think they could do with some renaming and stuff, but I think that it's not actually that bad.
Yeah, and these are also falling under the curse of the cyclic dependencies and having to pull the model and the view and these separate files. Yeah.
And I think that could actually be broken down. I think that could be stopped, but it's sort of not worth it. Like you actually get something from having the view in its own file a little bit. It's only because sometimes the views need sorry, it's because we have a bunch of events defined and the events take some globally defined things, or some model defined things that are hard to change. But I think that is not a flaw in the Elm architecture. That is a flaw in some definitions, and we could actually break that down.
Okay.
What else we got? Canvas.
Canvas and app, yeah.
Honestly, couldn't tell you what's in Canvas. There we go. So viewport is the space, top bar, obvious, sidebar, obvious. Can't remember what scaffold is. Oh yeah, it's just like extra.
Like utils.
Yeah, just like view stuff. And then yeah, there's error rail, there's documentation, there's the overall view thing, which sort of owns everything. A lot of these try to be components in kind of their own way. You kind of see that there's sidebar with view sidebar. So I think these some of them could be divided into components nicely. And then these are sort of the part of like running the actual app itself. So browser listeners is a good example. That is something that sets up subscriptions to things that change in to browser events. Window events. We don't need keyboard events because those are kind of built in, but on focus events, that sort of thing. And then the save setting and saves user settings are kind of app wide. Variant testing is what we call the client side feature flags, not part of the dark product, but like if you want to set some things. And then integration tests and the app types, those are kind of global things. And then main is actually the overall owner of everything. So this is, I don't know, a couple of thousand lines of like, this is where the magic happens. And really this file should not do anything. It should not do anything interesting at all. It should be just like the scaffolding that ties all the components together, but that is absolutely not what it is in any way now.
Okay.
Like if we did this well, this would be 500 lines of pure scaffolding.
Okay.
Yeah. So maybe the app types is a good place to start on like moving down. And if you go to the very bottom and look at the model.
Yeah, so there's the default here, and then the models right here.
So how familiar are you with the Elm architecture?
Pretty familiar.
Okay. So yeah, so it's sort of, there's a global state. There's a bunch of messages which are supposed to convey any sort of interaction that happens, such as API calls, keyboards, mouse, etc. And then there's commands, which are ways to communicate with the outside world. And we stick to that-ish. Like definitely there's some things that change URLs directly. And there's some things that are not Elmish, like we do random number generators, which is like in Elm is state, but we're just like, fuck it, it's not worth tracking that everywhere. And for the most part, we have done messages and so we've done messages pretty poorly, in that we
There's
have
like modifications and there's messages and there's like
well,
a few
so
systems.
if you just look at messages, which I think is not this is modifications.
Yeah, this modifications.
So you'll see that, like, you know, there's top level delete, there's top level delete forever, there's like all of these sort of belong to the two subcomponents, but we don't treat them as belonging to subcomponents. They're like in one big global thing, and that for sure should be like cut down into componentized messages, with each component having its own message definition, and then it just being pushed to the components.
Okay.
So like you can see there, you know, really good example of this is like, well, you were just there, but like delete 404 API callback, something like that.
Yeah.
Yeah, it's like, that's, you know, that's kind of ridiculous that this is like top level global.
And so the idea is we slowly tease these out. So we slowly tease out functionality into these components, including the messages and such.
Yeah.
Okay, good.
Exactly. And then so we have modifications, and modifications are not part of the Elm architecture, but what they are for us is a way of doing cross-component communication, basically. And because our components are a mess, there's a lot of like, oh, this component needs to talk to this component. And some of it makes a lot of sense. So like select, an awful lot of places, an awful lot of components want to say what is selected next. So that's the sort of thing where it kind of does make sense in a way, but really this shouldn't have been like, you shouldn't return a set of modifications. You should instead, there should instead be a set of functions, basically. And then you know, a component sends back which functions they would like to call, and then the main dispatches it accordingly. But that instead we have a lot of places that return modifications, which is the same thing as I just said, except this is global, and I would like each component to be able to define its own set of, you know, you could call them modifications. I started calling it effects. That are then sort of translated when we go back. We have done some stuff to move away from it. In particular, there's one modification called replace all modifications with this one, which uses a more standard model of like take a model, return a model, and a command. And the vast majority of top levels could be replaced. Sorry, the vast majority of modifications could be replaced by that, and we would like to get to a world where they are. And then we can remove modifications. Yeah, so that's kind of the main overview of how everything is structured. Where should we go from here?
The questions I mostly, so I've been looking through the fluid code base lately and trying to fix some bugs there. And I guess I'm having difficulty with finding the seams between where the Elm-like stuff ends and other stuff begins. For example, like I'm kind of used to imagining Elm files or Fable files or whatnot that are you know, like following the explicit model update view kind of architecture there. And so I'm kind of like looking through these files and trying to find, okay, where are the things where I'm going from the model to what is rendered in the view? Where's the functionality where it's going from you know, a model and a command to the new model. And those lines are really fuzzy. And so if there's a, so that's like the problem that I'm trying to solve.
One of the reasons for that is that there's kind of a lot more app than there is just kind of like architecture, if you know what I mean. So like,
I don't.
If you've got a form, right? You've got a lot of pages that are just kind of forms. You got a SaaS app or something like that.
Yeah.
There's going to be a lot of that. But when you actually when you have a lot more app than you have browser interaction, it starts being, and this is the case in Fluid, it starts being dominated by, how the actual app is structured. And so there's, it's sort of like if you have a HTTP server that does not too much, you're going to see a lot of like methods and status codes and that sort of thing. And then once you get to actually my app does a whole lot of stuff, then it's like the methods of the status codes become less important. Methods, I mean like HTTP methods like get and post. Those things become a lot less visible because so much more of code is actually dedicated to the app. So that's why you're not seeing that much commands. So stuff like Fluid, there's not that many commands. It's kind of like, here's where we put the cursor, here's what the keyboard was, or here's what keyboard input we got. And then there's, I would say, tens of thousands of lines of what the app actually does in between receiving keyboard or a keystroke and sending back where to put the cursor.
And
similarly, like the views that are involved in, like there's very little view being created in, you've got 10 lines of code. There's not very much view going on there. There's like 10 lines being displayed, but there's the function for like what happens if you press left or right or the space bar at every single point in this thing. So maybe it'd be worth going through like what the key parts of this are. Okay, so
yeah, that would help.
Okay, so we'll start at Fluid. Maybe start at Fluid AST.
Okay.
You can do the Resi. So this is a simple wrapper around a Fluid expression. And this exists because these are top levels and sometimes Fluid expressions. So when you're modifying an AST, right, or an expression, right, you could be modifying the middle of it. And it's difficult to know whether a function is it supposed to take the entire AST or is it supposed to just like work on an expression? And so Fluid AST is just a type, and really all it has in it is an expression. You can see the type T on line 15 there. It's just, there's nothing there. But it's saying the contents of this is the entire AST, not a sub AST.
Okay.
So at the moment, every Fluid thing is on an AST. And can you open a dark window there? Maybe it's best to sort of relate this to.
Yeah.
Okay, so yeah, given a REPL is perfect there.
Okay.
So what Fluid is interested in, can you delete the null? Just anything that goes in this box at any point. So above this, the sidebar, anywhere in the canvas, just completely unrelated to Fluid. It lives in this box. So let's type a simple thing like.
And it's either in like this box or the feature flag box. Those are the only boxes where Fluid lives right now.
Yeah, or the functions, but they're all the same kind of.
Yeah, different boxes. Yeah.
Let's just talk like let x equals 10.
Okay.
So every time you press the key, that was processed by Fluid. And then Fluid turned those expressions into the HTML that we see here. And every time you go to modify this, there's a lot happening here. Getting confused. Okay.
Yeah, I was just pulling up these windows in case we need context of seeing the ASTs and whatnot.
So yeah, every time we do anything here, in this box, it's all being dealt with. So every keystroke that happens, dealing with where the cursor lives, every time you move something, and every time you make a change, Fluid makes that change to the AST, makes that change to the expressions, and it really doesn't do much else. So like the analysis isn't really related here. The API is there, you know, that all is kind of like shunted at the back. And Fluid just really deals with the updates. So
yeah,
if you press, so the major sort of changes that there are is like where does the key go? So, or where does the cursor go when you press left, right, up, down? There's what happens when you delete. There's what happens when you insert, and there's the autocomplete stuff, and then there's stuff around clipboard and selection. And there's not very much else. It's like really, you know, I guess Fluids can be thought of as the interaction between like making an editor that feels like you're typing code, even though it's a structured editor.
Yeah, so conceptually that makes sense. I guess what I'd be looking for longer term would be like that idea to be represented in code. The idea that you have an input and there's a union somewhere that illustrates here are like the possible kinds of actions and the details, and then here's a function that takes us from that input to the new, you know, cursor position and all those different outputs. So like that,
yeah, I mean,
the thing that I guess I'm missing, because I get that and I can, you know, walk myself through Fluid Res and like slowly trace my way through an interaction.
Yeah, I mean, if that was easy, we would have done that.
Okay.
There's it is quite difficult to make this some sort of like declarative, you know, keystroke thing. There's a lot of edge cases to make this look good and feel good. And actually it doesn't even feel good. It feels directionally right as opposed to like really good. But even that like directionally right took a lot of you know, sometimes you press a backspace and it's like got to do something speculative to see if that does it, and then it does it, and then it gets the result of it, and then it says, okay, that one makes sense, and then it goes back and does it. And so there's a lot kind of going on. But maybe let's go back to the code and sort of talk through some of the key concepts there.
Okay.
So fluid.res, I think, is where almost everything lives. And if we scroll down to somewhere in the middle of the file,
pattern blanks.
Stop at any function here. There we go.
Okay.
In placeholder expression. So when we've got an empty yeah, and what is it? An empty, maybe let's do something slightly simpler and go up to the previous one. Go and maybe insert in blank expression.
Okay. Yeah.
Yeah, so the
You want to try again?
Yeah, just kind of just scroll slowly, and I'll tell you what is a good one to start with.
Okay.
Maybe that match thing that we saw a little bit lower. Insert match out.
Insert add
Add-
match pattern net.
Yeah.
Okay.
So yeah, this is a good example. It takes, it takes an AST info. No, that's actually not a good example. Okay. Maybe let's go down to the main part of this where we do keystrokes and kind of start there.
Okay. Yeah. This is to explicit
That's
backspace.
a good example. So there's
Cool.
a do explicit backspace function. There's a do explicit delete function. And these ones sort of like fully encapsulate what happens when you do a backspace. And it's literally, so it's a switch statement, and you can see that in 2724 between the where we are now in terms of what AST ref we're on. So an AST ref is a description of the token that we're in now. So you have expressions. Expressions are converted into tokens, and that's sort of like a reverse parser. So it's like a token is something that can be laid out on the page in HTML or text.
Right.
Then an AST ref represents a specific place in the AST. And so what we used to do, and what we still do through a logic code base, is we used a cursor position, which is integer index from 0 across the entire AST.
Yeah.
And that was a pretty solid like description of where the thing is, because for any position you can find the token, and then the token has the ID, and you can tell how far you're into the token. But it has a bunch of bugs in it. And you ran into one earlier, when they changed the display for some reason, then the old position no longer reflects the actual thing, and so on. So we created this concept of a caret target and an AST ref. So caret target is, this is a good example. Where are we in a string? So line 10.
Yeah.
Where are we in a string? And it's basically an AST ref and an offset.
I think we want fluid cursor types. Maybe that's what we want.
There we go. Yeah. So we have this AST ref, and it's like, where are we in the AST?
So for example, in the
exactly.
Yeah. And then not only that, but I saw that, like, let's say we're in like 3.14. This doesn't give us the full context because it doesn't know whether we're in, before the 1 or after the 4. But there's this part down here, caret target, right. That offset is that offset, right? So 0 be the 0th part. Okay.
Exactly. And so it takes away a bunch of information that's in the token, and that's kind of it's kind of deliberate. Can you scroll down?
What information does it take away?
Well, there's no ID, for example. So sorry, can you
scroll up?
So if you had a token for the list open, like on line 50 here, that would have an ID in it, and it would or if you had like the keyword, it would, well, no, that's not a good example. If you had the variable, it would have the variable name in it. And so it deliberately omits this information, but you can tell from the very top level AST ref what ID it is, and then you can sort of go down. So so if you scroll down a little bit there.
Okay.
So here we have,
Oh, okay. So this, I see.
yeah. And so
I guess here's it better.
yeah, so the AR list has a list part. And so it's like, the list part tells us it's the, it's the open token or whatever. And the tuple part, like there'll be a comma in there, and the comma is, is numbered. So kind of, we are in a list number 17 or whatever. So
Yeah.
you can
So-
always go to its parents.
Yeah. So in like this example,
Yeah.
if I throw on the debugger here, I'm at this position. I have an AST ref that points to this whole node and this part. And I guess the offset tells me I'm here specifically.
Yeah.
Okay.
That's good. That's a good. Yeah, so AST refs, caret targets tell us where exactly we are when we're trying to like understand where in the AST we are, and then we use an integer when we're talking about where we are in the like positionally. And so the flow then is expressions create tokens. I think tokens are used to create AST refs, but it might be expressions, I'm not sure. But the tokens get us to text, and tokens also get us back to the AST. But caret targets are sort of a condensed version of what thing we are dealing with here. And so when we were back in fluid.res, so we are matching, let's maybe 274 is a good example here. So we just did a backspace. We did a backspace in the whole number. So this is on line 2747.
Okay.
So we know that the backspace was in the whole number, and we have this e float, which represents a thing. So we now know that we're going to go in to the whole number and to do a mutation on the whole number, and then we're going to return the new e float. The mutation is like a backspace on an actual string, which is mostly used for things that are like straightforward mutations. And then there's a lot of edge cases, but and then we return, we're in, we return the new position because we have to go set the thing. So like by returning this new position, we get no matter how it changes as a result of it. So like it moves to a new line, it has parentheses removed or added, that still represents the same place in a way that an integer position doesn't, and it will later, after rendering, be turned into an integer position. So this file is just tons and tons of, in this condition you do this, in this condition you do this, this condition you do this.
And is there like a predominant source that calls stuff in this file? Like, like I know keyboard listeners eventually end up calling this, but
yes,
is there like a general flow?
I think there's a function called update or update underscore maybe in this file. So like this is everything fluid lives in or is owned by this file. I think we've probably, there we go.
There you go.
Update message is, or yeah, this is where
okay. So here's the fluid message. Okay.
a very large amount of this is trying to manage the intersection between the forms thing and the fluid thing. So like who owns the browser cursor, for example. Making sure that we turn off the forms stuff when we get to the fluid stuff. So I think when we get rid of the forms thing, this will be a lot simpler. And like if you look on like 5911, for example, it's like dealing with the cursor state. The cursor state was where we are in the forms editor.
Where we are in the forms editor. Okay, so we focus on a token, and I guess this is where the cursor state was before we clicked on to focus a token. So we're going from this to this or something.
I think it might be this to another TLID. I think maybe it handles both.
Okay.
Yeah, but honestly, couldn't tell you what's happening here at all.
Okay.
But well, let's say 5925. There, it's like we have to move the viewports to make sure that the thing that we clicked on is like focused in the middle or in the right way.
I see. So it's like if we're kind of out of context, and
yeah,
I know sometimes it like drags you into space.
Yeah, exactly.
Okay. It's probably more like when you have a function that references another function and you click on it to navigate there.
I think that's right.
Okay.
So
oh yeah, because usage. Okay.
Yeah. So maybe I'll go through what each of the files do.
Okay.
So I think fluid AST, sorry, fluid AST is like the definition of the AST. Fluid commands is any sort of refactoring commands, and also whether they appear in the autocomplete, I think is. I wouldn't make any changes to this. There's been a relatively big refactor in the merge I did.
Okay.
Well, actually, maybe we should get it down. But a command is like a refactoring.
Okay.
And then commands.res. Is the definition of them as a, and not all of them are fluid or fluid based, but the idea is let's connect this to a keyboard shortcut. Okay.
Okay, so we have refactor down here.
Yeah.
Okay. So these all take, so I'm just going to look at one of these wrap things, like wrap with if. So this takes a wrap location, I think it's location, an ignored model, top level, and an ID. I guess the ID is the AST ID.
The idea of the expression that we're, I guess, wrapping probably.
Yeah. I know it's not going to be committed, but maybe we'll change that name to be more clear. Okay, and then we have some modification, which is probably always one of these specific kinds of fluid modification.
I imagine it's going to be like a set AST mod, which is send it to the server, we're still update the model, that sort of thing.
Okay. All right. Rail. Okay, that makes sense. I can look through that.
Okay.
All right, so that takes care of fluid commands.
Let's look at fluid view. Maybe it's fluid editor view. Not sure which it is. Play icon to HTML. So to HTML is, yeah, I think this is it. So scroll down until we get to the meat of this. There, maybe here.
Yeah, from
So
token.
takes all the tokens, converts it into HTML, makes CSS classes from it, makes figures out, does it need to have like a play button on it, looks at analysis, looks at precedence. I think it does, no, this doesn't do reflows. So that's done in the generating the token. You can see here that, in every token, we're getting the analysis ID, we're getting the text, we're getting the ID, and we're sort of turning to this HTML all happening in here.
What is an analysis ID and how does that relate to the token?
An analysis ID is, so when we do analysis, each expression has an ID. And so we store values with the, we store results in the analysis results so that, when you click on this thing, you can see the thing. So the analysis ID is for this token. This is the ID that has the right token information. So maybe a way to think about this is, let's say that we're on let x equals 5. So
yeah,
5 is an expression that has its own ID, but let space x space equals space. Those are all separate tokens. I forget whether I think spaces are tokens as well. And so on each of those, do we show something? Do we show nothing? What is it that we show? So when you're on the x, you don't want to show the result of the entire expression. All right, you don't want to show the result of the let, because that will be the let body. That
got it.
Yeah,
I guess I was surprised. Yeah, I guess I was surprised by it there being a separate ID rather than it being like an AST ref or something like that.
For the analysis ID.
Yeah.
I mean, we need an ID. Like it doesn't seem like a AST ref or a cursor token would achieve that.
Okay.
So let's go to fluid tokenizer. Well, maybe the fluid token first. I can sort of see how these things are created. And is there a definition here? Fluid types.token.t. Let's start there.
Let's go to fluid types. And these commands, tokens.
Yeah. Okay, so we can see, all of this is the important information related to a token. And each individual expression is broken down into a set of different tokens. And then sometimes there's extra information, like you see a lot of them have the parent block ID. But a token typically has its content alongside its own ID, and some of them will have extra IDs. So in the if we look at the tlet keyword, 78, the one that we just discussed.
Okay.
So we can see there that it has the ID of the expression that it's part of, but also the ID of its right-hand side, because whenever you're on a token, you want immediate lookup. You don't want to go back to the AST to try to figure out what's next to it. That's all done as part of tokenization. So we can see here that there's a token for every textual thing that appears on the page. It gets kind of complicated with like new lines and that sort of thing, but like that's generally the idea. Everything that's on the page has a token, and that token has enough information to figure out, you know, if you're going to make a change, where it goes, etc. And then
And you
sorry,
mentioned reflow. Is reflow the concept of just when you new line and whatnot, or what?
it is when you new line, when you we display a function as you know, f
Like with the underscore?
or f new line indented argument 1, new line argument 2, new line argument 3. Do we split strings over multiple lines? So like how do we do multi-line strings? And then is a line too long? How do we do it? And all this is like pretty primitive in terms of how it's kind of how it is done. Like the reflow is not like a very good reflow, but it has the kind of tools to do it well when we implement better algorithms.
Okay.
You can see it's also very easy to allow users to specify their own indentation, which is something that I plan to add to soon. All right, so let's go to the fluid tokenizer. And scroll
down. All right.
Okay.
Maybe up.
Keep going up.
Token.
So, yeah,
neighbors.
Tokens for
Are you looking?
So yeah, there we want. Have a look. Go to the definition of tokenize with FF. Well, actually, yeah, that one works better. Tokenize.
Oh, well, that's just this.
Okay, and then so builder. Yeah, this is basically what happens. We, start with like a builder thing. We tokenize it, then we tidy it, then we validate it, and then when tokens are in their final thing, we produce info-wise as we produce like the integers of all these things, which is used in a lot of places. And to tokens is the interesting thing here.
Okay.
So scroll down. Let's keep scrolling a bit. Let's keep going. But nice simple one on line 3 or 4 here. A blank token produces a blank thing. So like, let's add it to the token stream. It's literally just like a list of tokens. We don't use list because this thing is actually like on the rendering. Like it is a very hot thing that is called a ton of times. It should be called a lot less, but it's this had to be made reasonably fast. Okay, so you can see the elet here, right? Where first we add the keyword, then we add the var name, then we add the assignment token, which is the equals. Then there's the right-hand side, then maybe there's a new line needed, and then there's the body.
Okay. I noticed that there is an added new line if needed, but there's not a add separator, like a space between here. Where does the, I guess what's the decision making of like when of what belongs here versus I saw there's something called tidy.
So I forget what tidy does. I don't think it's that interesting.
Okay, maybe it's not it.
But
okay.
The keyword knows that there's a space after it. The assignment knows that there's a space before and after it, because there's no option that we all
just universally. Okay. see.
They are done in fluid token.toString.
Okay. You want me to go there?
Yeah. Or maybe it's to text or something like that.
Is white space is skippable as atoms, new lines let.
So you can see there's a lot of stuff in here, and
Yeah.
there's
Yes, probably you're looking for to text.
And
So
it's
for
also
example, if I'm looking for the tlet, there is tlet assignment.
yeah.
Okay, so they're just kind of baked in.
Yeah, exactly. And it also contains, like, you know, for this space, who is the owner of the space in a sense.
Okay.
A
And
lot.
each of these strings are, because so at the end of the day, the fluid stuff is painted onto the screen, and it's like HTML, right? That's content editable. So there's a span or something that's surrounding this.
Yeah, that's right there. In fact, take a look at the have a look at the HTML here.
You mean in code or in dark?
You're in the right place in the editor.
Okay. So I see this 10 here.
Oh.
So we have a span, and so we have this ID. And what ID is that? Or let me see if I can.
That is the ID, like the ID, whatever you get from fluid token.toID.
The token ID. Okay.
Yeah.
Okay.
And so you can see, like, literally it's just a list of IDs, and we do the syntax highlighting in CSS. And if you zoom out a little bit, you can see it's just like one big long stream of IDs or of spans.
Yep.
That do very little, and each of them contains a bit of text. None of them contains HTML. They're literally just text inside.
Okay. Out of curiosity, what's the precedence for?
For precedence. So there is work in there to show you, if you do X plus Y plus Z,
Okay.
to show you, or let's say X plus Y minus Z. We want to show you where the parentheses are.
Okay, so like operative precedence.
Yeah.
Okay.
We used to have we used to show precedence by, like, highlighting, and then we tried different colors. We tried, like, shading. They're all kind of confusing, but, like, the code is still there because we haven't decided how to do better.
Yeah, and I've seen some hints of like parens as well.
Yeah, so the parentheses is the next attempt.
Yeah. Okay. I'm curious to see what it looks like where, so let's say a function call has is impure, and it's going to call out to like a DB set. I don't think I have a database, but just I'm curious to see the HTML and the path of that. So if I create a bogus DB,
So,
and I'll do DB set of DB. I did DB here by accident. Yeah, let's spell this. It's bogus, but I've been wondering where this little play button comes from and how that fits into. Okay, so that execution button is like this.
yeah.
Okay.
So that's kind of everything. There's a fluid keyboard, there's fluid patterns, which has, functions on patterns. Shortcuts are just ways of creating patterns. It's not a whole lot. Like, all of it kind of falls into these like relatively straightforward concepts. There's just a lot of code associated with like doing that right.
Yeah. Yeah, I definitely need to look more into set AST mod and how that relates to the state that we
Well,
maintain, because we don't maintain a ton of state.
So set AST mod basically returns a set handler every time. It doesn't.
Okay.
And really what we would like to do is when we change, if we press the key, there should be one expression which gets persisted, and one expression that goes the whole way back and comes down and gets sent via pusher. That's not what happens. What happens now is the entire handler goes. And so when you have a large handler, like the performance is really bad.
Okay.
Yeah.
Yeah, I'm trying to think what else to ask here. Yeah, I understand tokenizer. I have token printer. Just I assume takes that.
Largely is.
Oh, so this is unrelated. Yeah, this is for integration test,
Largely
right?
tests.
Autocomplete handles if I'm in some blank and I'm typing characters and autocomplete's there.
Yeah, it mostly only works in expressions, and it really needs to be expanded to support more than that.
Look where else. Like I know in match it sort of works. Like you have that autocomplete there. What other non-expression stuff does it need to extend to?
I'm not sure actually.
Okay.
Probably just like more kind of commands. Better sort of like intersection between commands in it.
And feature flags generally behaves the same way. Like the little editor that pops up over here basically fits in the same space. Is there much difference to be wary of there? Those boxes.
Yeah, like feature flags are awkward. Fluid works really well in that one pane, and when you add an extra pane, it gets not so great. And there's probably a bunch of bugs in it.
Okay. And I guess fluid text input is some interaction with the keyboard, or is that like more paste, or what is this?
That's what it looks like, yeah.
Okay, so it looks really
yeah, because it gets an integer, I think. Yeah, when you figure out where something is. Actually, I think a lot of this is about insert text. So basically keys don't really work as how your database or how your key mapping works, because sometimes you're dictating and it loads it all in at once, or you're you've got a key bound to do multiple things, or delete content backwards or delete word backwards. You get that from the OS, not just the someone pressed Alt backspace or whatever. So we need that stuff is to ensure that we're not just re-implementing what the OS has. forgetting what the user.
How much of
would happen.
yeah? How much of a bear is it to migrate from forms to fluid?
So we would need to change. We would need to extend the concepts of like AST refs and tokens and everything to do to include
It's like
everything.
this. Yeah.
And then we would need to extend how it gets sent back. So this one would be, instead of being an AST mod, it's now a set the method on a REPL thing. So those are, relatively straightforward. I think it's going to be a lot of fucking around with the machinery. But I think getting it done for handlers is a good place to start. I wouldn't do it for DBs. Handlers and functions are the right place. So if you go to a function.
Yeah.
So it's got a bunch of stuff that is forms, so the name and the parameters. And so the interaction between all of them is kind of poor. And we don't allow you to set a description. We have description in the model, but we don't allow you to set a description because it's not sort of intersecting. So I think there's a lot of value in getting that, and I think handlers are the easiest place to start.
Okay.
I think after handlers could do functions, and then I wouldn't do databases until we actually change the representation of databases, because databases are going to be types in the future, and so making it work for the schema part of the database is only really useful as part of getting rid of the form, and it's not actually like useful in its own way.
And so this whole box here would effectively be painted by fluid. Is that fair?
Yeah, everything except the traces. And so the stuff on the side and the bottom, no. So
right.
Until the end of the word data store, 3 lines up, 4 lines up. Yeah, up until there, from the whole top left, yeah.
Including this?
No.
Okay.
So what we want to do is we'd want to have some sort of like syntax for it. So, this might look like, maybe it just starts with a name, and then there's like a parentheses or that sort of thing, and then the parameters are, I don't know if they're comma separate or whatever, but like, when you start to add in them, you get the frames and the structure added, or the snippets or whatever. So we'd want to start by defining the interaction model. And then once we've defined the interaction model, I think making it work wouldn't be the worst thing. We could remove the dragging things in the short term and bring them back later. And a lot of this stuff doesn't work anyway. So like you can't change the return type. So that could be something. Oh, maybe you can change the return type.
Yeah, you can.
Oh, you can. Okay. Yeah.
But there's no like parameterized list of this.
Yeah. And so I don't want to add parameterized types to forms. That's something that we want to do as part.
Yeah, don't invest in it. Yeah. How does that rank on like your priorities, the forms?
I mean, I think a good balance between adding user accessible features and removing trash and getting us to a good place to move forward. This isn't necessarily like a feature that we sell to users, but part of the overall feeling of using Dark is like, oh, the editor is a little bit off. And we don't see bug reports from it because it's just like, oh, I have to click this twice or something. You know, it eventually works. And we can see this in like the flakiness of the UI tests, of the integration tests. So like this is definitely something where the app will feel much better and will enable more things and will get rid of a lot of trash. So yeah, it's pretty valuable, but it's hard. So it might be something like to take a run at and see what you learn by doing it, and sort of abandon it halfway. It wouldn't be the worst idea.
Okay.
Yeah, and feel free to refactor and annotate and whatever along the way. There's definitely a whole lot of you know, kind of unpleasantness.
Okay. Yeah, this helped. Let's look briefly at the state that we maintain for, so we have the fluid state. Maybe that's not the thing I was looking for.
Fluid state,
app
pressure
types,
states are the
maybe.
two things that say where we are.
Yeah. Fluid state. There we go. Fluid state, and the cursor is somewhere around here. That's fine. And these are to deal with the cyclic dependencies, the fact that we have these typings.
Yeah, that's right.
Okay.
There's a nicer fluid state defined in app types lower.
In app types lower. Oh yeah, there's this. I see.
The use of these types are a key part of how Elm allows componentized models. That like you specify that it's returning a fluid command or a command with a apostrophe CMD instead of a concrete CMD like we have on line 1078. Then the translation is made by the caller and then the types unify. And part of the reason that we haven't been able to break those views apart is that we have utility functions that use the concrete global command.
I think one of the things I need to do. So my main, I think what I need to do is look at the functions within this giant file, and kind of draw out some dependency graph. I guess I have a hard time like scrolling through all of this and having a feel for going from the state we represent to certain types, for example, like the flow between that maintained state and the token is just kind of, it's in here. I guess this is all mutations, that doesn't really fit. Yeah, this is all.
I think one of the I would avoid focusing on the scaffolding. Because the scaffolding comes from, like, the need for the scaffolding comes from experience with the modifications or the editing it. it can be
Mhm.
very difficult to see why there's scaffolding some of the time, and it's, you know, even the comments there, you know, they could certainly be a lot better.
Mhm.
Definitely. Did you see that there was a record thing there, record action maybe?
Yeah, I saw
As you're
something
doing-
called record or report.
Yeah, as you're doing any, it's the record action there. So like that saves it to put it in the debugger. Anything that you do here, the debugger is like the way that you, not the Elm debugger, the built-in fluid, or the our fluid
Yeah.
debugger will tell you like everything.
Yeah, the one thing that I was reaching for that we don't have, maybe it's something we can add here, is let's say I have some code like is when we're selecting something like this, we have context of the selection start, and we have context of the AST or the node at the end. I guess I would also appreciate seeing more context around the selection start when we're selecting beyond just this. Maybe if I could like click into this.
Like to figure out what carrot tokens are there, that sort of thing.
Yeah.
Yeah.
And
Yeah,
to get like the ID quickly of this, and
yeah, I mean, certainly as we build it out, you know, so left and right are kind of helpful there. They tell you what it's on.
yeah, what tokens next? Yeah.
So that's that is where the cursor is, and so the cursor is on 4, and so that is what token is to the left and what token is to the right.
Mm-hmm. Yeah, I guess what partial token or carrot target.
Right, instead
Because
of
it's the same. Yeah, this will be the next full token.
yeah.
So this reports out to
The debugger,
modify state. Okay.
the thing we just saw.
Yeah. Okay. Great. I think that's all of the questions I have.